Okay folks, so today we're going to do a little bit of chemistry, and unfortunately we are not in the lab, so we can't do the practical that goes with this, but you have a rag sheet in your assignment, and this is the explanation of what it is that you are going to do today. So our learning intention is we are going to understand the differences between metals and non-metals. Okay, so pause that and put it into your book, and the first thing you're going to do for me, and you're going to have to go back to your Form 1 notes, is you're going to draw the periodic table roughly, so just the outline of it, like so. Doesn't have to be a work of art. And you are going to tell me, where do I find periodic table, or where do I find metals, which side, and roughly which side do I find non-metals. So you're going to have to go into your Form 1 notes to find that piece of information. Now, we would be doing this activity or something like it in school, where we'd have our Bunsen burner and our tongs, and we'd be sticking different things into the Bunsen flame to see would they melt. So unfortunately we can't do that because we are not in school. So you are going to have to do a little bit of Google searching for me. So I need you to find the boiling point for aluminium, for copper, for iron, and for zinc. And you are then, has to be Mr. Google to do this, you are going to rank them from the lowest boiling point to the highest. So you make a list, and I want you to think, do you consider these boiling points to be low or high? So they're going to be one or the other. You can decide. You might know more once we get to the end of this. Also in school we would have tried this. This would be more of a demo than anything else. So we'd have the four different metals. We would put a little piece of Vaseline down here at the end, and we would stick thumbtacks onto them, and we would heat the metal back here, and we're looking to see which of the metals do they all conduct heat? Is there one that's really way better than the other? And if it does conduct heat, it melts the wax and the pin falls down. So what you're going to find for me today is you're going to have to use Google to do this. You put in the search term, which metal is the best conductor of heat, and you should get a row of pictures, at least I get it at the top of Chrome, and the highest or the best conductor is over here, and at the very far end the worst of that list is over there. And I want you to find the metals again. So it was aluminium, it is copper, it is iron, and it is zinc. So you're going to find these and you're going to rank them from worst to best in terms of heat conduction. So we would also have done something similar to this, whereby we would have made a circuit with some wires, we would had a power pack, and we put a bulb in here, and we put the thing that we wanted to test between these crocodile clips, and something happens to the bulb depending on what you put in between the clips. So for us, the search that I want you to look at, or firstly have a look at chapter 17, and then if you can't find the answer, and it is in chapter 17, but it's what happens to a light bulb if I use a metal to complete the circuit. And once you do that, you're going to tell me what happens to the bulb and decide, does this make metals conductors of electricity? So yes, they are conductors, no they are not. You're going to also find out the meaning of these words, and these are in chapter 17. So these are words that are associated with metals. So lustrous, malleable, ductile, and sonorous. So that will definitely be in chapter 17. So figure out what those words mean. Doesn't need big long explanation. One sentence will suffice. So then there are some weird metals. And for these first two questions, you're going to try in chapter 17. So why are alkali metals different to other metals in terms of their density? And how is mercury different to other metals in terms of its state of matter? So you'll find the answer to both of those in chapter 17, but you are going to have to Google this last question. There's only 3 metals that are magnetic. Find out what they are. So then we go on to alloys. And again, the answers to all of these should be in chapter 17 for you. So I'd like to know, what are alloys? It's only one sentence. This is an example of an alloy. You may be able to figure out what this picture is, once you've figured out these guys. So solder, steel, brass and bronze, they're all composed of certain metals. I want you to find out what they are. And the last thing I'd like to know is a use for each of those alloys. So solder, steel, brass and bronze. And again, all answers in chapter 17. So quick Google for me. What are smart alloys? Because they are pretty cool. It won't be in your book. And now we go to look at non-metals. So in a weird way, non-metals have the kind of opposite characteristics for metals. And they don't have a lot of properties when you compare the list of metal properties. So most of these should be in chapter 17. Okay, so what state of matter are non-metals usually? What can you find out about that? From there, you're going to have a look at the boiling points. So Google is your best bet. There is a little bit of information in chapter 17, but I want you to find out the boiling point of carbon, of oxygen, nitrogen, and of sulfur. And I would like for you then to rank them again. So make a list from lowest to highest. And do you consider these boiling points to be low or high? So you can now, so CF is just Latin for compare. You can compare the boiling points now to the ones you found for metals, and that may help you to answer the question, are these low or high boiling points? So again, we would have had a look at whether or not non-metals are good conductors of electricity. So chapter 17 first, and if in doubt then Google. But it's what would happen to a light bulb if I use a non-metal to complete the circuit. So I want you to say what happens to the bulb when you find your answer. Does this make non-metals conductor of electricity? And there is another word that could be used instead of conductor for a non-metal. That is in chapter 17. Definitely. So have a look in there. And again in chapter 17, carbon is a non-metal and it exists in a number of different forms, and these are two of the forms. So this is a thing called graphite. We use it in pencils nowadays, and we use it in hockey sticks, in tennis rackets, and versus diamond. So there are two forms of carbon, and in chapter 17 graphite has a property that makes it seem like a metal, and diamond also has a property that makes it seem like a metal. So have a look and see, can you find them in there? And your homework for this, once you've done all of your research, is you can make me a poster, and I want you to compare the properties of metals and non-metals. You can arrange it however you want. You can split them in two. You can just do the metals down one side, non-metals down another. You may decide that you want to do little comparison things all over the place. You might have weird facts, however you want to present. I would like colour. So for my minimalists in the room, I am looking for facts. So birdie pictures will not do it. I am on Zoom for the duration of this. If you have any questions, have fun.